Okay,
Yes, sir.
thanks. Okay, so this KTG actually it relates the macroscopic properties of gas. What is macroscopic properties of gas? Some important macroscopic properties are pressure, then you have
So the
temperature.
thermodynamics, sir. In thermodynamics, there will be macroscopic values like that, sir. Pressure,
Yes, yes,
volume,
yes, yes,
temperature,
yes,
number
yes.
of moles.
Correct, 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 correct. So it
Yes, sir.
relates the macroscopic properties of the gas to the microscopic properties, to the microscopic properties of the gas molecule. See, it is gas, and now we are doing microscopic properties of gas molecules. Gas molecules like you have speed, momentum, kinetic energy, degree of freedom, so kinetic energy, etc. These are the microscopic properties. So kinetic theory of gases, it relates. It tells us the relationship between macroscopic properties and microscopic properties. Now there are certain assumptions that has been made in this kinetic theory of gases. These assumptions are important to note because sometimes direct question has been asked in NEET exam for like which require you to memorize some of the assumptions. So, and most of the assumptions you can just do the guesswork. It's like um, ideal gas molecules, how it should behave, all those things. So let us look into the assumptions. So assumptions are obviously extremely small particles. Gas molecules are extremely small particles in size. They are round in shape. They are elastic in nature, right? And uh, okay, small, round, elastic, and they are we cannot. So yeah, these they are rigid. Okay, so rigid and so small, round, elastic, rigid, and identical gas molecules. This is one of the assumption. In most of the book, these assumptions are written separately, like gas contains extremely small gas molecules. These gas molecules are round. These gas molecules are elastic. They are rigid. Okay, we have written it in a single statement. Then what are the other assumptions? Other assumptions are these gas molecules, they move randomly in all directions with all possible velocities, with all possible velocities, all possible velocities. Okay. Then what are the other assumptions? Other assumptions are this. I'm writing here itself. Okay. So these gas molecules, they keep on colliding. So they continuously collide. I'm directly writing they continuously collide with who? Gas molecules. Gas molecules continuously collide with each other and with the container sorry, with the container walls continuously. And this container walls collision leads to pressure. So pressure exerted by gas is due to the collisions of gas molecules with the walls of the container. Okay. Now, these gas molecules, they collide fine, but before collision, they travel a distance. They travel a linear path that is called free path. So there is a concept of free path. So one molecule, before hitting another molecule, it covers a distance. That distance is called free path. And the time and the time travel and the time taken by the molecule to travel this particular free path is called, see, relaxation time. Tau is called relaxation time. What is relaxation time? It is the time between it is the time between two successive collisions of gas molecules. Later on, we will see that how we can use this tau and free path to determine other properties. Okay.
Yes, sir. I'll just write, sir. So the second point moves randomly in all direction with all possible velocities, sir.
Yes.
Okay.
Gas molecules move randomly in all directions with all possible with all possible velocities. With all possible velocities. Means we cannot predict that the gas molecule is having, let's say, one gas molecule is moving with 20 meter per second. We cannot say that within a fraction of second, what will be its velocity. It will change. Continuously, it is changing. Okay.
Yes, sir. 2 minutes, sir.
Yes. There are about 20 to 25 there are 20 to 25 assumptions. So I'm trying to squeeze all those assumptions in few sentences so that everything will be covered up.
Sir, what is free path, sir?
Hmm? Free path.
Oh, yes, sir.
It is the distance traveled by a gas molecule before collision with the other gas molecule. Okay. And it is interesting to note that this random behavior, we are unable to generally, most people don't understand that what is randomness. So one example that we usually give to students who are studying in first year and second year of universities like Cornell University and Purdue University, they have also this KTG actually, those who are taking physics or thermody. So there is one beautiful example that we normally give to them so that we will discuss. Is it done? Have you noted all this thing?
Yes, sir.
Okay. 1 minute is left because earlier the pertaining to earlier class. So let's start again.
Yes, sir.